So it has a negative sign just to indicate yung phase relationship between components of the signal. Pero in the calculation, we take yung non-negative of the values of your JO just to solve for your BC. Calculation ng every voltages. So we need the values ng mga J's from your Bessel function. For the sideband separated. For your calculation ng carrier power, so yan naman, makakompute natin kanina sa BC from dito ay dito. Ayan. So encourage siya first 5 sa Bessel function. Very into direct substitution lang naman sa mga formula. There. Total power, ayan, just twice the mga sideband powers para doon naman siya. Makompute mo yung total power. Is parang isa-isa lang yung nako-compute dito. So twice mo since magkabilaan din naman yan if we check it in the frequency domain. Ayan siya, if we look into the frequency domain. Okay, how about bandwidth formulas for frequency modulation? Okay pa kayo? Hi guys.
Mabilis sa
Review nga naman to. Kumbaga, you can go back with the calculations. Bibigay ko naman sa inyo lahat to itong sa file. Since we have 2 more na PowerPoints. Napagdaanan nyo naman na to, Peter, yung sa mga events, mga examples. Okay, bandwidth formulas for FM. If hindi nyo talaga mag-grasp, sabihin nyo preno, sir, wait, para ba nakuha. Pero madali lang kasi grasp, very lang din naman siya, direct dun sa mga sa formulas. Okay, bandwidth formulas ng frequency modulation. So just twice the number of sideband. Approximate naman, it is using John Carson's formula, twice ng sum ng modulating frequency and the modulating deviation, the deviation frequency. Pag narrow band, just twice. Kapag wide band, twice the deviation. And ito, bandwidth ng previous example. Basta pag approximate bandwidth formula, just the twice na using yung John Carson's formula. Or yung theoretical, yun yung minsan binabanggit as approximate bandwidth formula, twice na modulating frequency and then yung number of highest needed sideband. So parang yun, pag MF natin is 3, so number of highest needed sideband is 6. So 2 times FM times 6, yun yung pwedeng approximate bandwidth formula. Or yung Carson's formula naman pag hindi binabanggit or pwedeng pag binanggit yung Carson's formula. Pag hindi binanggit yung approximate, ito yung gagamitin ha, yung theoretical. 2 times the modulating frequency times the number of highest needed sideband. The frequency modulation and noise can actually just like taken as vectors. Noise voltage can be random variations in the amplitude from the signal taking yung sa resultant. Yan, frequency modulation and noise. So ina-applyan siya ng limiter. So signal before limiting with the spikes created by noise, and then after from the limiter, ayan, magiging flat line na siya. Advantages ng frequency modulation over AM, yung amplitude ng FM carrier remains constant. So increase in the signal to noise ratio. So yung with an increased signal to noise ratio, it will produce a less noise. It is possible to reduce noise still further by increasing deviation and fitting with the amplitude limiters. Tapos less adjacent channel interference yung pwedeng mangyari because there are guard bands between your frequency modulation stations provided by your FCC and their CCIR, yung consultative committee ng international radio. Your guard bands. Guard bands cannot be occupied for station. Kumbaga, ito yung in between mga frequency FM stations para nga maiwasan yung interference. Pero in some cases, since limited din naman yung mga frequency FM stations yung kanyang area, pwede nilang i-reuse yung same frequency na yun kapag magkalayo na yung sa area para lang ma-maximize din yung gamit since basta wag lang sa mga magkakalapit na area, there should be a guard band. It's possible to operate several independent transmitters on the same frequency with considerably less interference. Ang same frequency pero dapat magkalayo masyado ng area. Hindi sila magkaroon ng interference. Co-channel interference kapag magkaparehas sila sa may frequency. Disadvantage lang, a much wider channel is required by FM 7 to 15 times as large as needed by AM. So since wider channel, mas malaking bandwidth, so it is costly as well. So mas malaking power din yung kakainin. FM transmitting and receiving equipment tends to be more complex pagdating sa system technology part. It is complex, particularly for modulation and demodulation, therefore more expensive. Also, since reception is limited to line of sight, the area of reception ng FM is much smaller than AM. Kahit pansinin nyo dun sa bandwidth, 88 to 108 pag FM, pag AM, ano naman pag AM? 525 to or 535 kapag international. Philippines 525 to 1605. 1605 kilohertz. So sa FM 88 to 108. Capture effect. So it is the inherent ability ng FM to minimize yung effect ng undesired signals, which are the noise, apply to the reception ng strongest signal or stations and minimize other signals operating on the same frequency. So parang yung sa noise reduction characteristic ng AM, well to interference. So we could say yung stronger signal captures the receiver. In fact, yung property ng FM is usually called yung capture effect. Yan nga yung capture effect. With the stronger signal, it captures. Block diagram ng FM transmitter. So paano naman? So audio and then kakaroon ng pre-emphasis na network. May boosting na nangyayari. Dito from your audio, from your message signal or the modulating signal, nagkakaroon ng pre-emphasis na network. So may crystal oscillator ulit which produces the carrier wave and the output then fed into the phase modulator. Exciter this the means of providing an FM and RF signal. Your modulating signal is fed now into the audio amplifier, also to a pre-emphasis network, wherein your frequencies in the modulating signal are made to have equal power. Yung output ng pre-emphasis going to the exciter is then amplified and sent for the phase modulation. So the modulated output is the power amplified using a power amplifier, and then fed into the transmitting antenna for the transmission. So for the pre-emphasis na part dun sa ito yung katumbas na circuit for a pre-emphasis na circuit or pre-emphasis na part dun sa block diagram ng FM transmitter. The boosting of the higher modulating frequencies at the transmitter in accordance with the prearranged curve to improve noise immunity. And the pre-emphasis FN and prevent the higher frequency component of the transmitter intelligence being degraded. So also we have a de-emphasis na katumbas naman the reduction of the amplitude ng higher modulating frequencies at the receiver. So there's a pre-emphasis and de-emphasis networks have a time constant for 75 microseconds. Sa Europe, yung ginagamit is 150 microseconds and 25 microseconds for Dolby. Mga cut-off frequencies of 2122 Hz. Special note, if two modulating signals have the same initial amplitude and one of them is pre-emphasized to twice this amplitude, whereas the other is unaffected, being at much lower frequency, then yung receiver will naturally have to de-emphasize the first signal by a factor of 2 to ensure that both signals have the same amplitude in the output of the receiver. So may pre-emphasis to transmitter, may de-emphasis naman on the part of the modulation or on the reception side. Forms ng interference in frequency modulation. So meron tayong tinatawag na image frequency, your IF, effect ng two stations being received simultaneously. Co-channel interference, mobile receivers when traveling from one transmitter toward another, this minimizes by the capture effect ko. So yung capture effect ng sino yung mas reliable or the highest frequency, yun yung mas sensitive na kukunin niya or i-adapt niya. Adjacent channel interference created between tuning to adjacent stations due to the imperfection of filters circuits like channel 2 and 3. Yan, image for your AM and FM. Na pag sa may peak, ano yung mga nababari na characteristics of your carrier signal. Stereophonic FM multiplex system. Ito, modulation system in which two channel system with left channel and a right channel transmitted simultaneously and independently. Ito, ginagamit na siya sa mga televisions, wherein a stereophonic FM system uses 38 kHz subcarrier from a pilot carrier of 19 kHz to produce some indifference ng two channels. Generation ng FM signal. So first we have yung direct method, varying yung frequency ng carrier oscillator directly. So isang ginagamit is yung reactance modulator for the FM transmitters. Ito yung katumbas naman na circuit for a reactance modulator. Reactance ng capacitive or the inductive components of the tank circuit vary in direct relationship sa audio signal, which causes now your oscillator to vary directly producing an AM. Pag varactor diode naman is varactor voltage variable capacitor. When reverse bias exhibits a junction capacitance that varies inversely with the amount of reverse voltage. Mga indirect method yung ginagamit is the Armstrong method. So modulating signal is modulated using balanced modulator, then fed into the summer device, summing device together with a crystal that is shifted 90 degrees wideband na FM, then obtained by successive frequency multiplication in the output. Ito for direct methods. The Armstrong method. Ay, ito pala. Yung for the indirect method. So the FM is obtained through your phase modulation, crystal oscillator, then going to the buffer, my combining network, sidebands only. First group of your multipliers, result, medium and low frequency, and then the low, class C, and then going to the antenna. So ito yung block diagram ng Armstrong method, Armstrong method for the indirect method. So yung mga important dyan, meron yung audio equalizers. So it also uses phase shifters. So yung unmodulated is being shifted 90 degrees. And then added in a combining network. And then yung output of the combining network, we get yung FM wave. And then being raised using now a mixer. So it uses, yung Armstrong, the indirect method uses phase modulation to generate yung frequency modulation. Ayan, kaya laging pinagsasama yung frequency and the phase modulation as an angle modulation kasi in some systems, in order to produce nga yung frequency modulation, ginagamitan na siya ng phase modulation. Kaya let's discuss phase modulation. So phase modulation wherein the phase of the carrier is made proportional to the instantaneous value of your modulating signal. General equation naman for phase modulation na wave. So ito siya, VC sin omega CT plus MP sin omega MT. Just like parang yung frequency lang tama, wherein you have here your MF naman for the modulating index for the frequency modulation. Where your modulating index for the phase modulation, kaparehas lang din just like doon sa pag-compute din sa FM. You have your proportionality constant, still at hertz per voltage. Under identical conditions, we can say that the modulation index for phase is equal to the modulation index for FM, but when your modulating signal is changed, rather, so your MP is dependent now sa K, thus your MF can now be changed. Diba, if titignan natin yung relation, ayan, ito yung mag-sum up dun sa calculation pag we have phase modulation or frequency modulation. Paano pag sa deviation? Pag frequency modulation, di ba proportional siya sa VM? Pag sa phase modulation naman, proportional to the VM and independent of your FM. Sa modulation index, pag sa frequency modulation, MF is proportional to your VM and inversely proportional to your FM. MP is proportional to VM. Ano ba sa katumbas ng mga formulas? Tapos pag FM is changed, your MP will remain constant. Ayan, sa modulation index. Pag sa phase modulation, di ba ito is your K1VM or your K1VM. Pag dito lang sa frequency modulation, your modulation index is yung K, VM, and inversely proportional to your FM. Ayan, over FM. Pag sa max frequency deviation, so ito, proportional to your VM, independent on FM. So K1, VM, FM. Proportional naman yung sa VM. So it is K2, K, and then your VM. There. example, ayan, equation ng angle modulated wave. Calculate yung maximum deviation, rewrite yung equation if the modulating frequency is half and remains constant, assuming that the wave is frequency modulated, and paano kapag phase modulated. Nandyan pa kayo? Hi guys.
Sure.
Ano makailangan natin to rewrite the equation if the modulating frequency is half? So, kailangan natin i-compute yung FM. Tapos, assuming that the wave is frequency modulated and kapag phase modulated. So, ayan, kailangan muna natin i-compute yung FM, 318.31. And then your deviation, MFFM. So, the maximum deviation is around 6.37 kilohertz. So, in the paano natin i-rewrite? So, frequency modulated. Ano yung makailangan? So, kailangan natin yung MF. So, magiging 40 na yon from the 20 kapag it's being half. Your FM being half. So, from 390 naging 159 na lang dito. So, magiging 40 na yung modulating frequency. So, papalitan mo lang dun yung 20 kanina magiging 40. Para pag phase naman, it's the same. Since from the property nga, it will remain constant when FM is changed. Since independent naman din siya sa FM ito, for phase modulation, so same din lang yung sa phase modulated general equation. Modulating frequency is half, so it's independent sa pag-compute natin nung sa deviation, so it will remain unchanged, your MP. Nakuha? Okay, next we have now. Kaya pa?